Hi, this info session will illustrate how Copernicus supports local and regional authorities for monitoring and reporting duties for the European Marine Strategy Framework Directive. The quality of sea waters in coastal areas need to be monitored for many purposes. There are various European directives which involve different elements of the coastal environment and which identify targets to be reached within a given time frame. One example is the Water Framework Directive issued in 2000, which set a series of objectives and means to reach the so-called good status for all the surface and groundwaters in the European Union, with the current deadline set for 2027. The Marine Strategy Framework Directive was issued in 2008 and establishes a framework for community action in the field of marine environment policy. It leads each member state to build a strategy in order to reach or maintain the so-called good environmental status by 2020. In order to identify and implement actions to reach the good status and the good environmental status, the two directives define a set of elements to be assessed and monitored. For the Water Framework Directive, a set of environmental indicators has been defined to be monitored up to 1 nautical mile from the shore. The Marine Strategy Framework Directive defined 11 status descriptors to be evaluated on marine waters up to 12 nautical miles, that is, territorial waters. Examples of such descriptors are biological diversity, eutrophication, marine litter, etc. For both directives, the first assessment cycle of the current status was completed, and this made it possible to define the monitoring requirements and to identify the gaps in current practices. Such practices are based on the periodical service, involving dedicated ships, instruments, and personnel, and are able to cover only a small fraction of the coastal areas, usually with a monthly frequency. Furthermore, it is critical that the same parameters are monitored by bordering member states, and comparable methodologies are adopted. The Marine Strategy Framework Directive has been implemented by each member state into national law, and in particular by appointing a national referent, by defining a monitoring strategy at national level, and by identifying one or more bodies responsible for the measurements. A representative example can be the Italian implementation, which is common for most member states. In Italy, the national referent is the Environment Ministry, which appointed a national body, namely ISPRA, the National Institute for Environmental Protection and Research, for the reporting duties, and as a scientific guidance for defining practices and parameters to be monitored. ISPRA is also responsible for talking to bordering member states to agree on common methodologies. Finally, regional environmental authorities physically perform the survey campaigns. Currently, remote sensing of water quality from satellite is a practice that has been done for more than 20 years. It can provide reliable results with large area coverage and high temporal frequency. Many scientific studies assessed how remote sensing measurements of water quality parameters can be a valid complement to in situ surveys in order to address and overcome their limitations. The current sensors largely used for water quality monitoring are the MODIS and the VIRS, which have been recently complemented by the Sentinel-3 missions. Concentration of chlorophyll A, water transparency, and sea surface temperature are an example of parameters useful for evaluating some of the Marine Strategy Framework Directive status descriptors. Thanks to current satellites, they can be monitored several times per day, covering large-scale areas. In the following demonstration, we will show how measurements of the three mentioned parameters can be easily obtained exploiting Copernicus services. The software used is the Sentinel Application Platform, in short SNAP, which is a free tool provided by the European Space Agency, the ESA, for processing the Sentinels and other remote sensing data. The Copernicus Marine Environment Monitoring Service, CMEMS, provides a set of products which can be freely accessed, for example, through the illustrated web catalog interface. We will use 3 products, all provided at a spatial resolution of about 1 kilometer: the chlorophyll concentration, the sea surface temperature, and the vertical attenuation coefficient for downward irradiance at 490 nanometers, usually referred to as KD 490. This is, as an example, the main page of the sea surface temperature product over the Mediterranean Sea. To enter the download page, we click on Download Product. This is the download page of the dataset Mediterranean Sea Remote Sensing Reflectances and Attenuation Coefficient at 490 from multi-satellite observation reprocessed. It contains the measurements of the KD 490 parameter. On this page, the geographical area can be selected, as well as the time range and other information related to the type of product. A single day is selected here, 31st of August 2015, and downloaded. The same is done for all the 3 products considered. As a further example here, the download page for the European sea surface chlorophyll concentration from multi-satellite observation is shown, which covers all the European seas. We launch the Snap toolbox, and on the main interface we selected the icon for loading a new product. First, we open the sea surface temperature, from now on also referred as SST. The name of the file contains information on the type of product, with a final ID related to the download time. Most of the CMEM's products are in NetCDF format. Snap is able to understand the right NetCDF type, so we keep the one proposed. After the file is loaded, Snap shows its structure and content in the Product Explorer window. In this case, a series of bands can be found in the product, including the mean sea surface temperature value for the initially selected day, time 1, and the next 5 days. By double-clicking on sea surface temperature time 1 band, the content is displayed on the screen, projected on the fly in the geographic lathlon reference system. The band is shown as a grayscale layer. The bottom left color manipulation panel displays the image histogram. The measurement units are Kelvin degrees, and allows us to assign various color scales for our color palette, predefined and customizable. They can also be loaded. We can load, for example, the CC General.CPD color palette. It is a text file. Within Snap, we adapt the palette to the minimum and maximum range of the values of the considered image. The slider at the bottom can be used to adjust the distribution of the intervals of the color palette. For example, this icon allows us to make the intervals regularly distributed, improving the qualitative evaluation of the content. We can also set other parameters by exploding the More Options panel. For example, we can assign a color to the No Data value. This is the resulting map of sea surface temperature for the 31st of August 2015, with no data values as black color. Now we load the next product. We select the product containing the chlorophyll concentration. The product loaded is the one containing the chlorophyll concentration, as we can see in the right panel. We open the band corresponding to the initially selected day, CHL time 1, by clicking on it. Another window is opened in the middle of the interface with the chlorophyll measurement on the fly projected in a geographic lathlon reference system. In the color manipulation panel, we choose to apply the log 10 scale to the default grayscale. After the log 10 scale is applied to the grayscale, we open a color palette. We choose the CC IOP quality .cpd color palette and apply it. This is the resulting chlorophyll concentration map for the 31st of August 2015. Now we open the product containing the KD 490. This product contains only one band with the desired KD 490 measurement. We open the band. As before, the band is displayed as grayscale and we load a new color palette. In this case, we loaded the CC General .cpd color palette. Also in this case, we applied the log 10 scaling. This is the resulting KD 490 map for the 31st of August 2015. Now we show how, using simple tools, we can calculate from KD 490 a first approximation of water transparency, intended as the depth at which the light is almost completely absorbed by the water. The simple formula shown will be used. Back to Snap, in the raster menu, we choose Band Maps, which allows us to calculate a new band by a given formula applied to existing bands. We set the name of the band as water transparency. The formula can be applied by entering the Edit Expression window. In this window, we enter the previously illustrated formula to the KD 490 band. By clicking OK, the calculation is done and the new band is opened and displayed automatically. The calculated water transparency is displayed as grayscale. To improve this visualization, we load a new color palette. For example, the palette Gradient Blue .cpd. We can manually adjust the color sliders. This is the final colored map. The lighter the blue, the more transparent the water is. We then move to the bottom left navigation panel. By activating such icons, we link all the views. We can zoom, pan, and switch through the various maps, and the displayed window will automatically synchronize. At the top of the displaying window, we can choose which map to display. Here, the water transparency map is displayed. This is the chlorophyll map, and this is the sea surface temperature map. Now we show how to export one of the obtained maps on the displayed area, for example the SST map, the sea surface temperature map, as a GeoTIFF file. We use the raster to subset menu. The subset tool is opened. It automatically uses the area contained in the display window. We launch it accepting the other parameters. The result is a virtual subset product with the same bands of the originating product. In the Product Explorer window, it has the same name as the originating product with the subset prefix. The map retains the same color palette of the originating product, but is clipped on the area of interest. You can see the gray borders around it. Now, in order to export this map as a GeoTIFF containing the sea surface temperature values for each pixel, we use the menu command File, Export, GeoTIFF BigTIFF. We select the name of the output file and save it. The saved GeoTIFF can then be used into GIS tools or remote sensing software or for statistical analysis. Please note that the displayed map here is with the color palette applied, but the pixel values of the said map contains the sea surface temperature measurement, in this case in Kelvin degrees. However, you can also save the color-coded map. Thank you for watching.